Okay, so this is the first problem in your homework. So let me just adjust this and write the title here. So solutions to homework 1. And this is summer 2021. So you want to simplify this, and we want to express the simplified answer with positive exponents only, or we want to write the final expression with positive exponents only. So from here, we use laws of exponents. So we will have negative 4 raised to negative 2, then x raised to negative 3 raised to negative 2, y squared raised to negative 2, z raised to negative 1 raised to negative 2. That's for the numerator. And for the denominator, we will have negative 2x raised to 3 raised to negative 3. Then y raised to negative 2 raised to negative 3. Then z squared raised to negative 3. So that could be your first step in the solution. And then you simplify everything. For this guy here, we can write it as 1 over negative 4 quantity squared. Okay. For this guy here, we have negative 3, negative 2 as exponent. So you multiply these two. You will have x raised to 6. Same is true with this. You have 2 and negative 2. You multiply them. You will have y raised to negative 4. Then in here, you have negative 1 and negative 2. You will have z raised to positive 2. And then for this denominator, you have positive 3 and negative 3. So you will get negative 2x quantity raised to negative 9. In here, you will have y raised to positive 6. Then in here, you will have z raised to negative 6. Furthermore, for this denominator here, we distribute the power negative 9. And for this, let's just write this as, um, let's just write this as 1 over 16. So you will have 1 over 16. And then for these guys here, let's just rewrite them. So you will have x raised to 6, y raised to negative 4, z squared divided by, for this you will have negative 2 raised to negative 9, x raised to negative 9, y raised to 6, z raised to 6. And then we combine like terms. So, well, first you have this negative 2 raised to negative 9. You can rewrite it as, so we have the denominator here. You can rewrite it as 1 over negative 2 raised to positive 9. Okay? And of course, you have your 1 over 16 in here. And then here you have x raised to 6 in the numerator. And the denominator, you have x raised to negative 9. So what we're going to do is to bring up this x raised to negative 9 from the denominator. And of course, retain x to the power 6 on the numerator. So you have x to the 6, and then here you will have now x to the power 9. For the y, in the numerator, you have y raised to negative 4. Here you have y to the positive 6 on the denominator. So what we're going to do is to bring y raised to negative 4 down to the denominator. So you will have here y to the 6, y to the power 4. And finally, in here, you have z squared in the numerator, z to the 6 on the denominator. Now, the power of z in the denominator, which is 6, it's greater than the power of z in the numerator. Okay? So what we're going to do, the guy in the numerator, that's z to the power 2, we bring it down to the denominator. Okay? So you will have here z to the power 6, z raised to negative 2. Okay? So that's a correction in here. You have z raised to negative 6. And therefore, what we're going to do is to bring this z raised to negative 6 from the denominator going to the numerator. So that's my mistake. So in here we have now in the numerator z squared and then z to the power 6. Thank you. And then we just simplify this. This guy here you have here, if we bring this to the numerator, okay, if you bring this to the numerator, we'll get the reciprocal. Okay? If we bring 1 over 16 on the denominator, we also get the reciprocal. So what you will get is the following. You will have negative 2 raised to 9. And then you will have here 16. Okay? And then we simplify the x's here. You will the powers here. You have x raised to 15. Then z raised to 8. And then denominator, it's y raised to 10. And then, of course, we have these constants. If we simplify that, you will get negative. So in here, you can write this as negative 2 raised to power 5, and then negative 2 raised to power 4. You have here x raised to 15, z raised to 8, while on the denominator, you have 16. Your 16 can be written as 2 to the power 4. That's why I chose this decomposition for negative 2 raised to 9. I wrote it as negative 2 raised to 5 times negative 2 raised to 4. Because 16, that's 2 to the power 4. And then you still have y raised to 10 in here. But then again, negative 2 to the power 4, this is 16. And this is the same as 2 to the power 4. Which means that these two guys here, this guy here and this guy here, they just cancel each other. So the simplified version will be negative 32, x raised to 15, z raised to 8 over y raised to 10. So this is the final expression for this guy here. Okay?
Sir,
Yes?
I had one more question.
Sure.
So here, sir, where you go to like -2 to the exponent of 5, like just above that, right there, all the exponents are positive.
Uh-huh.
How come you can't stop there? Is there because you can like simplify it more?
Yes.
Okay. All right. Perfect.
Yes.
Thank you, sir.
You're welcome. Take note that the actual problem, the first instruction in the problem is simplify the expression. So
Okay. Okay.
if you don't simplify this negative 2 to the 9 over 16, then you did not follow the instruction of simplifying.
Okay. Thank you.
You're welcome. Other questions? Let's look at now the next problem. So the next problem is we want to factor the following expression. So you have y to the 4 minus 14y squared minus 32. Okay? So, well, this is a fourth degree polynomial expression. Okay? And we were just factoring what? Most of the time, the squares and the um, cubes, if possible. But as you can see in here, this is an expression quadratic in form. So how do we see that? Well, if we let x equals y squared, okay? If we let x equals y squared, then this expression can be written as x squared minus 14x minus 32. Okay? So from here, let us first factor this expression. And then once we have factored this, if we have written this in factored form, we bring back y, okay? And then see if we can still factor. So from here, we use our method, okay? A it's equal to 1, okay? So anyway, we will not need this. But we have B equals negative 14 and C equals negative 32. So remember, you want to find a pair of integers AB such that the product is AB and the sum A plus B, this is equal to capital B. So in here, you have C, a negative number. So we use one positive and one negative. Okay. So all throughout, this is negative 32. And then since B is negative, we want the factors A and B to have such that the higher absolute value number is negative. Okay? The higher number in absolute value, we want that to be negative. And then the lower number in absolute value, of course, will have the positive. So what I mean is, well, for example, negative 32. 32 can be written as 4 times 8. But we have a negative value here. One of them must be negative. And using the remark that I just said earlier, the B it's negative. We want the higher number here to be negative. So we want negative 8 here. However, if we do this, we will have 4 minus 8. This is negative 4. This is not the one we need. Okay? But anyway, let's go to the pair that we actually need. We will have 2 and 16. Okay? And we'll put 16 as negative so that if we add them, we'll get negative number. And if we actually add them, we will get negative 14. So this is the one that we need, this pair here. Which means that this guy here, we will have x minus 16 times x plus 2. Now we bring y back. So we will have y squared minus 16, y squared plus 2. And if you look at this, difference of two squares, so we can still factor. While for this guy, this is already prime. So we factor y squared minus 16, we'll get y minus 4 times y plus 4. And then we'll just copy y squared plus 2. So this is the final and complete factored form of y to the 4 minus 14y squared minus 32. Okay. So for our third problem, we want to add or subtract the following. So for number 3, we have 21y over 2y squared minus 2y minus 4, then minus 17y plus 3 divided by 2 times y minus 1, y plus 1. Okay? So in here, we'll do this by looking at the LCD first. Okay? Looking at the LCD. So first we factor 2y squared minus 2y minus 4. So we have 2y squared minus 2y minus 4. Obviously, we can factor 2. So you have 2 times y squared minus y minus 2. Okay? And for this guy, y squared minus y minus 2, you can use the method that we did earlier. Okay? So you can do that. And once you do that, you should be able to factor this into y minus 2, y plus 1. Okay? So this guy here, 2y squared minus 2y minus 4, it can be factored into 2 times y minus 2, y plus 1. Of course, in here, things, okay, the expression is already in factored form. So we can easily see what the LCM is. So LCM, you have 2. Both of them actually have 2. And then you have your y minus 1 in here. You have the y plus 1. From here, you have the y minus 2. And you have y plus 1. But we already have y plus 1 in here. Okay? And of course, power of 2 here, it's just 1. Power of y minus 1, it's 1. This does not have y minus 1. Y plus 1 here, power is 1. You have y plus 1 here, the power is also 1. Here we have 2, the power is also 1. So we'll just have those. And lastly, you have y minus 2, the power it's 1 also. So the LCM, it's just this guy here. So which means we can rewrite this difference here as follows. So you have 2, y minus 1, y plus 1, and then y minus 2. Okay? And then for this guy, which is this guy here, we already have 2, y minus 2, and y plus 1. So we are missing y minus 1 in here. So we have 21y times y minus 1. Then minus 17y plus 3 times. So in here you have 2, you have y minus 1, you have y plus 1. We are missing y minus 2. So we multiply this by y minus 2. Okay? And then we just simplify. In the numerator, we have 21y squared minus 21y. Then minus, so you expand this, use your FOIL method, use your distribution method, but we will have 17y squared. So that's 17y times y in here, and then 17y times -2, so minus 34y. Okay? And then 3 times y, so plus 3y. And then 3 times -2, that's -6. Okay? And of course, we'll just copy the denominator and retain this in factored form. You don't multiply them out. So you just retain that. 2 times y minus 1, y plus 1, y minus 2. The reason why in here we have to multiply it because there's a subtraction. Okay, there's a subtraction in this. You have this expression minus this expression. So you have to simplify this. On the other hand, here you just have multiplication in every expression. So 2 times y minus 1 times y plus 1 times y minus 2. Okay? So if we simplify this, you need to distribute the negative. For this, you can add or subtract. So you have minus 34y plus 3y. So if you have this, you will get minus 31y. Okay? So if we continue with the simplification, you have 21y squared minus 21y minus 17y squared, and then plus 31y, then plus 6. For the denominator, you have 2 times y minus 1, y plus 1, y minus 2. Simplifying further, we have 21y squared minus 17y squared. That's 4y squared. Here you have minus 21y plus 31y, that's plus 10y. And then you have the plus 6. So divided by 2y minus 1, y plus 1, y minus 2. We can still factor 2 in the numerator, and then we'll see if we can factor further. So you have 2 times 2y squared plus 5y plus 3. Then all over 2 times y minus 1, y plus 1, y minus 2. So your 2, they will cancel each other here. And then for this, okay, for this, let's try to factor. Okay, let's try to factor this. So we'll use the method. Okay, let us use the method that we learned from last time. So for this, you have A equals 2, and then B equals 5, and then C equals 3. So capital AC, that's 6. Okay, and you want to find small a and small b such that the product is capital AC. Okay, and the sum a plus b, that should be capital B. Okay, but in here you have what? You have here 6 for capital AC, and then let's just get a b equal to 2, b equal to 3, and you see that if you added them, you'll get 5, and that's our capital B. Okay? Which means this expression here, okay? This expression here, so let me squeeze that here on this part. So you have 2y squared, 2y squared plus the 5y will decompose it into 2y plus 3y and then plus 3. So remember, for this method, the middle part, you decompose it. And then you do your grouping. So you group this together and then this together so that you will get 2, 2y times y plus 1 plus 3 times y plus 1. And if you factor this completely, you will have 2y plus 3 times y plus 1. Which means this expression here, in the numerator, we can write 2y plus 3 times y plus 1. On the denominator, we'll just copy the 3 factors there. Y minus 1, y plus 1, y minus 2. And clearly you see y plus 1 here and y plus 1 here. So they will cancel each other. So that the final expression will be, in the numerator, you have 2y plus 3. On the denominator, you have y minus 1 times y minus 2. So this is the final expression.